That was such an awesome presentation, Ryan. I'm so hungry for spaghetti now. And one of the first questions we have is from 80-year-old Nick, who asks, if I dug a hole straight to the center of the earth, would I fall all the way through and keep falling, or would gravity stop me somewhere?
That's a very good question. So the thing to remember here is that everything that has mass pulls on you with gravity. So on the surface of the Earth, we're above all of the Earth's mass. So we're pulled straight down. But if you were to dig a hole straight through the Earth and out the other side and jump down it, you would initially be pulled right to the center of the Earth. But eventually, the gravity above you, or the mass above you, will pull you up more than the mass below you is pulling you down. So what ends up happening is that you actually kind of bounce back and forth, wiggling through the center of the Earth, like maybe a mass on a spring, if you've seen that before, just kind of bouncing up and down. So that's what would happen to you if you jumped through to the center of the Earth.
Yeah, right. And that's funny. I always thought that you would keep on floating through and come off the other side and come back, but
Yeah.
you'll be bouncing through.
Yep, you'll probably have a hard time getting out.
Right. Who knew? Which this actually raised me to a question from Joseph, who asks, does everything have a gravitational pull? People, phones, books, you and me?
Yeah, so that's a really cool thing. Everything that has a mass has a gravitational pull. It's just that the gravitational pull is incredibly small. So you could even think about an atom, say the simplest atom in our universe, a hydrogen atom. That has a mass, so it has a gravitational pull. But the mass of a hydrogen atom is incredibly small, like almost inconceivably small. So the gravitational pull from that is just effectively nothing. But if you have an awful lot of hydrogen together, then the gravitational pull can become very strong and you can make stars.
Yeah, right. So like James said, everything is jiggling a little bit, and in that jiggly spaghetti soup, everything exerts that force. That's really cool.
Yeah.
And that leads me to a question from Sky, who asks, how do you guys as scientists, physicists, find the mass of these things, of the Earth, of the Moon, of the Sun, to estimate the capital G, to figure these things out?
That's a very good question. So you can actually find the masses of objects from how they orbit things and a few other experiments. So we can calculate, say we drop an object on the Earth, it'll accelerate to the Earth. We know we can measure the acceleration of that object, and we know the mass of the object. And if you use, say, orbits to calculate the mass of the Earth or something along those lines, you can work out that if you do some math, play around with equations, you end up with an equation that says big G is equal to the acceleration and the distance and things that it travels and the time it takes to travel. So this is a really tricky experiment to do right. Because that number is so incredibly small, you need to be super careful with how you do the experiment. Otherwise, you'll just be measuring nothing pretty much.
That's so interesting. And funnily enough, what we will be doing in later this August as part of National Science Week. And that makes me wonder, Arakuna, she's wondering, that's things getting fast is all great, but how does it all start? How does gravity start? What causes it? Why does it exist? We don't know, right? Like, what are your thoughts, Ryan?
So the fundamental origins of gravity. Well, we can go. So what I've talked about so far is mostly what we call Newtonian gravity. So that's just kind of equations that describe the motion as we see it. The step above that is general relativity, which a scientist, which you may have heard of, called Einstein, developed. And general relativity is a lot cooler than Newtonian physics because it relates gravity to how space bends. So if you remember, I talked about gravitational lensing before. That comes down to general relativity. So that still doesn't really answer the question though, because would there be gravity if there were no particles in the universe? Probably not. Or if there was a space-time, we call it, to bend. It's kind of these are strange questions. Like even the most fundamental question of why should we expect there to be gravity in the universe? That's a strange question, which I don't think there's a good answer for at the moment.
Yeah, it's so funny how, despite of 500 years of science, there's so many questions we still can't answer, and that's why we've got all of these youngsters that we're hoping one day can help us find these questions
Yeah,
to the
it's
answers.
their job to solve gravity,
Yeah,
not my
they
job.
can worry about it, no worries. And Elliot, 6 years old, wants to know if you had to make Ryan a armor to protect yourself from falling into a black hole, what kind of an armor would you have to make?
That's a good
I think
question.
you would want to protect yourself from losing all of the information. Hey,
Yeah, so you, well, I guess the short answer is you wouldn't be able to make it out of any materials that we know of at the moment, because the black hole will strip it to pieces. There are possibly ways that if you have a really big, slow rotating black hole and you came at it from the pole, the spinning poles, you might be able to get close enough that you don't immediately get torn to pieces and maybe slip through. But material, I don't know. At the moment, it's in the realms of science fiction, but more often than not, the realms of science fiction become the realms of science given enough time. So
yeah,
maybe in the future, there'll be an awesome discovery of a material that, say, resists gravity's pull, which I would certainly make armor out of if I wanted to go into a black hole.
100%. To think that 50 years ago, we didn't know black holes existed, to now us being able to photograph them with the Earth-sized telescope, someone's dream became our reality, and we're able to now do these things that we would have not conceived possible at all.
Mm.
Um, and it makes me wonder, there's a couple of questions that I think are sort of related from Isla 12 and Felix 9 and Joachim and Michael. What? Why does the Earth not fall onto the sun? And I guess the related question is, why do things need to have mass? So, i.e., why don't liquids have as much gravity to be able to not bam into each other?
Right. So I'll start with why the Earth doesn't just fall into the sun. If you were to just take the sun, put it in the universe, and then take the Earth and put it in the universe, what you would find is that the Earth would be pulled into the sun and be swallowed by the sun. But what happens when stars form is the reason why the Earth orbits the sun. So you can imagine, if you can imagine, a massive cloud of gas and dust in space. Over time, it eventually starts to contract down and starts spinning. At the center of that big gas cloud that's contracting and spinning, the sun is starting to form. And around the sun, a big disk of material is running around it, which is trying to go into the sun, but probably won't end up there. And within this disk, little planets start to form. So all of these planets already form running around the sun. So that's the reason why they don't fall in. If you travel fast enough, you can run away from another object. The other point you raised, Manik, with why liquids can kind of just pass through one another, that's more to do with the state of matter. So liquids aren't bound together in a very rigid way, so they can just flow through one another and it doesn't matter too much. Gravity still acts on them. That's the reason we have tides in the sea, because the moon and sun's gravity tugs on the sea and makes the the water do weird things. But with solid objects, that's when you get gravity making stuff actually collide together and doing more destructive things.
All right. That's funny because you mentioned collision doesn't occur because of the forces that they apply on each other. And a couple of the young stars, Bella, Nadia, and Oliver, are wondering if there was a black hole, because they've got so much gravity, what would happen if they were to collide into each other?
That's a very good question. And it's a question that we actually have an answer to. Again, if you ask this question like, like 3-4 years ago, we would have had theories to suggest what would happen, but we actually have evidence and observations to tell us what happens now. So what happens is that these black holes actually merge together. And we can observe that with really cool instruments called gravitational wave interferometers.
It's a
in
mouthful.
particular, yeah, it's a long word, but the instrument that does it is LIGO, and it can detect black holes merging all across our universe. And it's really cool because you can kind of measure the masses of the two black holes that merge together and the mass of the final black hole. And you find that the final black hole is actually less or lighter than the two individual black hole masses added together. So what happens is as these black holes spiral in and merge with each other, they mess up space so much and put so much energy into warping space into weird ways that it converts some of the black hole mass into just energy to wiggle space. Very intense wiggles though.
Yeah, that's so interesting. And it's a wiggling space, and it almost changes the way normal things work, doesn't it? And makes me wonder, and Abriel and Michael and Karthik are asking sort of similar questions. So when black holes collide, is that how they die? And also, is that how the universe might die?
Right. So let's start the other way around. How does the universe die? So at the moment, it looks like the universe will just kind of keep expanding forever until eventually every particle decays in the universe or gets eaten by a black hole. So what we're left with is a universe with black holes scattered around the place. Now, there's a famous physicist called Stephen Hawking that some of you may have heard of before. He wrote some really cool books on physics. What's it called? Is it A Brief History of Time?
Yeah.
Yeah.
I know a few youngsters are actually reading it right now. Like, I don't know, David, who's 6 years old, is reading A Brief History of Time.
Yeah, so it's a really good book, and I do recommend you read it if you can. But what one of Stephen Hawking's main scientific achievements was, he showed that you would expect black holes along the event horizon, so along that black edge, to be radiating, or small particles to just be running away from the black hole. And this is what we call Hawking radiation. And the details of how Hawking radiation work are probably a talk in of itself, so I won't go into it in too much detail. But the simple takeaway is that Hawking radiation effectively takes mass out of black holes. And as the black hole gets smaller, Hawking radiation takes out mass faster. So the black holes eventually, in this dead universe, just black holes, will radiate energy away into space through Hawking radiation until they just pop out of existence. So that's the black holes won't live forever.
It's so interesting. I know a few young stars are wondering the funkiness of black holes and how they change our perception of time. And Karthik really wants to know, could it be possible that we're inside a black hole?
Yeah, that's a good question. Yeah, so I'll say this first. This is just speculation. We have no idea of what it is like actually inside of a black hole. But one idea is that perhaps our universe started from what we call a singularity, an infinitely small point in space, infinitely dense, that exploded in the Big Bang. That may sound familiar because I said earlier that a black hole had a singularity, which was an infinitely small and dense point in space. So it could be, we have no proof of this, again, I'll say, that behind or within every black hole, there might be a Big Bang happening somewhere else. But that is, at the moment, just a nice idea. We don't have any proof for it. If we're living in a black hole, it doesn't seem to be the case. And even if it were the case, it wouldn't really matter because the laws of physics seem to be consistent and behave the way they do, regardless of what we might find ourselves in.
That's so interesting. Hey, we'll never know unless we do. Maybe, and it brings me to my final question for today from Gabriel. Ryan, this one's mainly for you. Mm-hmm. What's your favorite part about space? Is it neutron stars?
Right. Not neutron stars for me. Neutron stars are really cool, and I have a number of friends who love those and spend a lot of time researching them. My favorite bit about space is, I think I'll say, the mystery. So although I spend my days trying to understand stars that blow up, it's not necessarily the stars blowing up that excites me. It's the mystery of trying to see if something different happens, if the universe is going to give us another surprise. So this, for me, might turn out to be a supernova blowing up star does something peculiar, which gives us new insight into how physics works in these extreme explosions. Another exciting thing would be if we found a world nearby that looked like it could support life, or even life itself, intelligent life somewhere in the universe. So the universe is an incredibly enormous place. Anything you could think of possibly is happening somewhere in it. So to me, the mystery of the universe is the most exciting thing, and the main reason why I keep looking and trying to understand what it actually is. Just trying to solve that mystery.
That's awesome, Ryan. Hopefully some of the young stars can find some of those mysterious things as well. We had so many questions today. Ryan, it's unbelievable, from Olga, Amaris, Jelena, April, Michael, Brian, and we haven't been able to get to them. But guys, believe me, we will, throughout this year, take through videos that we make and other sessions we run, try and answer as many of those possible. But please join me in thanking Ryan for an awesome talk about, and I really am, number one, hungry for spaghetti, number two, excited about black holes colliding, and have learned so much about gravity and really want to learn how to measure it. Thanks, Ryan. That was awesome.
That was my pleasure. Thanks for joining us, everyone.